From the box of discs above, well actually they're below here in the video, in the notes they are above, a sample of 5 is taken. Calculate the probability distribution of X and graph it. Now, in the notes above, X is described as the number of yellow discs that are taken from the box. So X is going to be the random variable number of yellows. And if I was writing this out for a test, I'd write it out more descriptively than that. This is the formula for the hypergeometric distribution, and indeed this is an example of the hypergeometric distribution. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So there's 30 discs. That means that big N, that's our population size, is 30. Little n is the sample size, and we're taking 5 discs. X is just the variable, so we're looking at the different values it could take here. And if we're looking at the number of yellows that we can get when we take 5 balls, we could get anything from 0 to 5. So if we had 0 yellow balls, that means everything that we've picked is red, or we could get up to 5 yellows. The K in this distribution is the actual population of yellows within the entire population. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So K is 9 in this case. So the probability that X is 0 is going to be 9C0. This is 30 take away 9, so that's 21. C n minus x, so that's going to be 5 since x is 0, all over n is 30, remember, 5. So we've got to calculate that. So let's put it in a fraction template. We'll have 9 C0, of course you can do this on the class pad as well, multiplied by 21 C5 all over 30 C5. And that gives us, let's just change that to decimal, 0.14. So if we go to 4 decimal places, that'll be 1428. And of course you can do that on the class pad as well, so we'll have a look at that as well. Now I'll do probability that x equals 1 on the calculator as well. Now x is 1, so that's going to be 9C1, 21C4 all over 30 choose 5. And you can see that that's getting 1 yellow from the 9 that we have and 4 reds from the 21 we have. Now hopefully that'll work on here. It will certainly work on your handheld, but I've had some problems with the online version of this calculator, so that's why I used the scientific in the first place. But just to show you where we find these things, and I think it's in advance. There we are, NCR, and we'll put 9,1 in there, and we'll multiply by NCR 21,4, and in here we'll have NCR 30,5. So just check those are okay, they're all good, and we get 0. So if we round that, it'll be 3780 to 4 decimal places. Now, while I'm not recording, I've gone ahead and worked out some of the other values. So we've got 3360 here for the probability that x is 2. So that's 0.3360. Remember, this should be a probability distribution, so when we've got them all, they should add up to 1. For 3, so we can see choosing 3 here, if we look here on the calculator, that's 0.1238. The probability x is 4. Here's the next one down. We can see the 9C4 in there. 0.0186. And finally, x is 5. This is a very small probability. We can see they've given that in scientific notation. So, actual fact, what happens if I do that? No, it's turned it into a fraction. So it's 0.0009 if we round it. So we're asked to graph it. Now, I'm going to do this quite roughly over here. You could actually make a slightly better job. So we'll have the value of x over here, and the probability of x being x up here. And so our highest one is 0.37, so let's make this 0.4, and that will be 0.2, 0.3, 0.1, and we have the values 0, 1, let's just change that slightly, 1, 2, 3, 4, and 5, and if I use a red line, so that's 0.1428, so that's going to be about, say, there, and then the next one is 0.3780, so sort of there. We can't do that this accurately when we're just doing it like this. 3360, so that would be a bit lower, and then 31238, so sort of there. 4 is 0.0186, so that's going to be tiny, and 5 is going to be even tinier, if I can even draw it. There we go.